There's a lot of activities that we can do in Johor. For divers, Johor why is very attractive. We have a lot of preserved islands in Johor. Pulau Tinggi, Pulau Sibu, Pulau Besar, and also Dayang. Why Mersing Island is very attractive? First, the marine life is well preserved because in Johor, we control the divers that come over for diving. We have deployed artificial reef from Jata Negeri Johor and Bangunan Sultan Ismail Artificial Reef, and also Tukulak Spana Coral Garden. So it's one of the preservation that we do in Johor Island.
There are activities that you can do in Andarompin Johor National Park. Trekking will take you about 3 to 5 hours to reach the largest waterfall that we have, the Buaya Sangkut Andarompin waterfall.
God, that was so much fun!
Legoland Malaysia Resort is an ideal family resort destination. It's a fully themed resort comprising a theme park, a water park, as well as a hotel, which the families and the kids can both play and enjoy as well. When we opened the water park, it was the world's largest Lego-themed water park, and we are very proud of that.
One of the things I would like to do is do a road trip. So when you do a road trip, you drive around all the different towns in Johor, in the various districts, and you discover the people, the places, and especially the food.
Assalamualaikum and hi, ladies and gentlemen. Our seminar will resume in a moment time. Please be ready. Hope you guys still excited and happy with us. A reminder to all speakers and presenters, please make sure your internet connection is okay. Thank you. Ladies and gentlemen, welcome back. Okay, we will continue with our fifth keynote speaker for today. Let me introduce Dr. Nur Fatiha Ghazali from USM. She is a coordinator of dental materials and lecturer at the School of Dental Science, University Science Malaysia, a member of Malaysia Biomaterials Society. Her expertise is synthesizing organometallic chemistry and materials science, where her research area involves biomaterials for dental and medical applications. Her current major research is developing a new polymeric hydrogel embedded with silver nanoparticles incorporated hydroxyapatite for wound dressing, patches, and regenerative tissue applications. Okay, her title for today is Fabrication of Hydrogel Nanoparticles Biocomposites for Wound Dressing and Regenerative Applications. I would like to kindly to remind that you all will have 25 minutes for sharing and 5 minutes for Q&A session. Dr. Nur Fatiha, you may start whenever you are ready. Please welcome. Sorry, Doctor, your voice is mute. We cannot hear your voice. Okay, Doctor, maybe you can go to audio, and then try one by one.
Can you hear my voice now?
Okay, yes, clear.
Okay, good. Sorry about that.
It's okay.
Okay,
Doctor,
can
you
you
may.
see my slide?
Yes, but it's not fully full screen. Okay, it's full
Okay.
screen already.
All right.
Okay.
Okay. Thank you. Thank you very much to the chairperson. Okay. Assalamualaikum and a very good evening. Before I start my presentation, first of all, I would like to thank the committee of BioNanoSem, especially Associate Prof. Dr. Nick Ahmad Nizam and Dr. Juan for inviting me as the keynote speaker actually, which I think I still I feel thankful and grateful for this opportunity to share and gain knowledge with all of you. So for this presentation, actually is only the surface level of my research, and I'm still new in this field. And I hope to gain, comments or any feedback or also question from the participant. Right. So for today's presentation, I would like to present part of my research, which is fabrication of hydrogel nanoparticles biocomposite for wound healing and regenerative applications. So in this research is a teamwork research which we have molecular biology cells persons, materials, as well as with the student. So this is the research collaboration and group members. So in this research, in part of this research, I one of the principal investigator. So we have Dr. Nohayati Yusof, one of the co-researcher in my research. She's a molecular biology cells persons expertise, and we also have Prof. Dr. Ismail Abdurrahman. She's a professor who is who been pioneer in USM School of Dental that developed these biomaterials, and also we have the collaborator Dr. Juan Makmin from UTM. So for the introduction, our research would like to focus on the regenerative medicine, where you can see here is the regenerative medicine of wound healing overview, where it consists part of it, the stem cell and biomaterial. So in our research group, we focus on the material and the stem cell, where this regenerative medicines therapy actually involve the administration of cell biomaterial as well as the biomolecule. So in this part of the wound healing, tissue engineering is the combine of the use of the stem cell, biomaterial, and growth factor, which it can generate to replace the tissue for repairing healing or non-healing chronic wound. And the additional of this wound healing actually is a very complex, which involve that can present more challenging regulatory path to clinical translation. So what actually is the wound healing? So wound healing is actually a dynamic and very complex process, and this wound healing happen when there's a sharp injuries on the human skin tissue. As you can see, when we have sharp injuries on the skin or human skin, we will encounter three classic stages of wound repair, where it consists of inflammations, proliferations, and remodeling of the skin tissue. So wound healing actually is a process that involves a series of biochemicals and physiological events, and the management and the managements and dressings of the chronic wound have presented a very major issue during during the recovery period. So wound healing consists of acute wound or chronic wound. So chronic wound have presented a major issue during the recovery period, and in addition, the healing process can also be delayed by a various factors. So as you can see, wound healing, also known as the cutaneous wound healing process, where it consists of hemostasis, inflammations, proliferation, and remodeling. Therefore, a delay or factor that involved in the wound healing may subsequently leads to a health and economic burden. Therefore, there is an immediate need to look into different types of wound dressing with a high biocompatibility and efficiency. So what is actually wound dressing? So what wound dressing is actually is a material or a conventional therapies for the wound healing that have been utilized in a natural skin. However, there's disadvantages when we use this conventional technique for the wound healing. So if you can see here in my slide, there's a wound healing wound self-healing process, where it come into the 4 stages, and it will take a long period. And we also have wound healing using the different form of wound dressing, where it started from the hydrogel that comes into the nano or microfiber scaffold, where it comes to in the film, form, bandage, or as well as the nano microgel. So how this wound dressing also that developed from the hydrogel biomaterial can works on when we have a open wound, it will be attacked by the bacterial invasions. So there's a partial fibroblast formation down here. So when we cover with this hydrogel biomaterial wound dressing, the cell migration will happen through the polymeric hydrogel membrane, and this will come to the wound healing by the attach of the hydrogel biomaterial membranes. So skin tissue engineering have arisen as one of the alternative, and the design of the advanced biomaterial will regulate the physical, chemical, electrical, and biological properties. And hydrogel is one of the potential candidate among the various biomaterial, and the utilizations of this nanomaterial in biomedical sciences has give a very promising future application. So this is one of the properties. This is the ideal properties of the hydrogels, and the condition that that can be used for to develop or to fabricate material for the ideal wound healing material which need to possess. As you can see, the properties here, we need to take account on the swelling absorption capacity, the porous structure antibacterial. We also consist of the bioactive molecule loaded, pH responsive, self-healing, as well as the water content, where this water content actually, where the network are similar to the extracellular metric and give a good biocompatibility. Why we need these properties? Because it's important to have an ideal wound healing material, where this ideal wound healing material can eliminate the wound exudate, allow the gases exchange and prevent the infection from the bacteria, and it also is desirable. We can have a desirable biological activities, the faintly acidic physiological milieu of the wound, tolerate mechanical deformation which caused by the motion, as well as the comfortable environment of the wound healing. So part of this research, we are using alginate, which alginate is the polymeric hydrogel. As you can see up there, there's a molecular structure of this alginate consists of MGM block, and alginate also actually known as a alginic acid, which have a hydrophilic chemical structure of hydrophilic polysaccharide that form a very viscous gel-like structure when it hydrated. It have a highly reactive and amenable for strong cross-linkage with other particles. It have a lot of hydroxy and carboxylic group along the chemical structure in their backbones. It been isolated from the brown algae. If you can see, this figure is the sodium alginate bit slide that been prepared. So it puts some colors and it become a bit grains, and the physical and chemical properties of this alginate actually are highly determined by the contents of M and G block. Actually, the natural color of this alginate is actually a transparent color, but this one actually they have some coloring put inside. So alginate hydrogel are often prepared by external gelling, which we use the calcium ion for the cross-linking agent. So alginate, there's a lot of advantage using the alginate for the application of wound healing, where it's very biocompatibility, inert nature, easy for gelation. Most important is a non-toxicity material. It can be very biocompatibility, regenerability, natural sources, as well as it's very low cost material. So part of it, we also use agarose, where we would like to combine the agarose and alginate. So agarose is red algae, also known as a phylum Rhodophilia. So it extract from the red algae. All right. So it naturally occurring polysaccharide, where it extract from the marine red algae and have a very unique self-gelling characteristic due to the oxygen and hydrogen in the side group, and it is very useful for the cell growth, differentiations, and proliferations. So the combination of alginate and agarose hydrogel provide very admirable properties to accelerate wound healing application. So this is part of the advantage of agarose that been used for the biomaterial in biomedical applications, such as architectural. It have an architectural structure. It can be tunable for wound exudation, water uptake, and gases formations, as well as a wound adhesion. It also have antibacterial features, cell morphology affected by the gel stiffness. It can encapsulate the cell and maintain the phenotype and spherical shape. And in the scaffold porosity, it can be adjusted with the desired tissue, as well as appropriate formation of nutrient. So in part of this preparation of alginate agarose, we tend to integrate or incorporate it with the silver nanoparticle. Why is it silver nanoparticle? Because silver nanoparticles have known for their antimicrobial properties, and is a very good material for the for this research, where for your information, pure silver nanoparticle can modulate anti-inflammatory cytokine release, and by inducing the differentiation of myofibroblasts from the normal fibroblasts, silver nanoparticle promote a wound contractility. So silver-based dressing have added benefit to reduce the number of metalloproteinases, and silver nanoparticle impregnated the hydrogel has more porosity, high degree of swelling, and higher rate of water vapor transfer. And moreover, silver nanoparticle also are more effective than other silver compound because of their wide surface area. So this is the application that been used, developed using the silver nanoparticles such as antimicrobials, human health, biodetection labeling, biomagnetic separation, environmental characteristic action, drug delivery, as well as biomedical application. So we also propose the method to add or to incorporate HA, hydroxide apatite, with the silver nanoparticle to combine with this hydrogel. So for your information, HA or hydroxide apatite is actually a ceramic with that is biocompatible with bone, and it used for orthopedic and dental implant especially. And although HA display low biodegradability compared to other calcium phosphate material, but it also give a lot of benefit, especially to the bone material component, and it's considered one of the few material that can promote bonding osteogenesis. So these are the part of the HA that been developed in bone substitute, implant coating, drug delivery system, composite implant component, as well as in dental materials. So in my school, in School of Dental Sciences in UTHM, HA is one of the popular material that been used, especially when they have a research in dental material or dentistry. So these are the table that shows the advantage and disadvantage of the natural biomaterial in the wound healing application. If you can see here, the alginate is one of the highest polymer hydrogel that being used for the wound healing application. However, there's no yet study have been done or proposed between the alginate agarose combination, and most of this natural biomaterial in the table have been incorporated each other, but no study have done on the alginate agarose that will incorporate it with the silver nanoparticle, and HA has the BioNanoComposite. So what is actually BioNanoComposite? In this research is to ensure that successfully dressing, which depend heavily on the better understanding of the healing mechanism, we have to also ensure this BioNanoComposite to have a property such as mechanical strength, value ratio, stimulus sensitivity, biocompatibility, or degradability, where we need to study and design for the successful of the composite. And in a nutshell, this goal of this research is to establish antimicrobial silver HA integrated with the alginate agarose hydrogel, has the nanobioComposite with a remarkable properties such as biocompatible, biodegradable, tunable mechanical properties, which to successfully speed up the wound healing process. So in this research, we come up with some problem statement where the current study actually have non-conclusive of the ideal property of the antimicrobial silver HA incorporated with the alginate agarose hydrogel BioNanoComposite that can be used as a wound healing application. However, there's also no proper characterization of nanobioComposite hydrogel without having the remarkable properties, and where this would give a bit difficult for the wound healing wound healing would be difficult to predict. So justification of this study is to combine the two types of the hydrogel and provide the moist wound bed, which is important criteria has the number study performed on the effectiveness of the moist wound area for the successful wound healing. The incorporation of the silver nanoparticle with the alginate agarose as well as HA wound care treatment, and expected to provide patient with ultimate care on the antibacterial properties concerned. And the importance of this wound healing is the key part of the life, which can impact an average human being lifestyle, health, and also economic term of an everyday life. And the most important is proper wound healing treatment can be provide excellent wound care management, which can lead to accelerated the rate of the healing. So this is very general and wide of the research objective in my research, where this actually the synthesis, actually we start with the synthesis of the alginate agarose silver nanoparticle hydrogel, where it have to we need to synthesize and investigate the chemical and physical properties, mechanical properties, as well as the antimicrobial activity, and to see how compatible or biocompatible of this wound dressing. So this is the stage 1 of the research, where we need to prepare the and synthesis the alginate agarose hydrogel. This is the proposed or the developed method in this research, where the alginate and agarose will be diluted in the buffer cell line, and then it will mix together under the condition of 37 degrees, and then it will form in the hydrogel bead. Why is it in the hydrogel bead? Because we need to characterize using the SEM and FDR into the form of the beads, and we will filter and washing, and hydrogel bead that form can be washed with 3 times of the PBS. So this is the synthesis of the silver nanoparticle. So as I mentioned before, this research is very surface at the level, and part of the student here, we still optimize the method, and we come up with this method for the synthesis of silver nanoparticle, where we need this we will use silver nitrate and trisodium citrate, and then we'll form the silver nanoparticle in a dry powder. So this is the part of the synthesis silver alginate agarose silver nanoparticle, and the composition will be developed and optimized respectively, and the silver ion will be residual and stabilized in the hydrogel, act as a capping agent, where it make the stable as a nanocomposite, and the probably will be dispersed randomly in the hydrogen and to make sure it will not leach out, and the silver nanoparticle will form at the site of the lowest Gibbs energy to ensure the homogeneous distribution. And this is the synthesis of a silver nanoparticle, where we use the chemical reduction. There's 2 parts, where we will add the trisodium citrate and we top the trisodium citrate. Why is it? Because we want to see the effect of the trisodium citrate, because this if we manage to do until the part of the patching or the material, we have to make sure so there's no chemical effects of the material. Okay, these are some of the stage 2 characterization that will be characterized using the universal testing machine, SEF scanning electron microscope, transmission electron microscope, UV, and Fourier and FTIR. We also will check on the swelling behavior of the hydrogel by using the freeze dry sample in the distilled water at the room temperature. So the third stage is the assessment of the antimicrobial properties. These are the methods. So to be frank, these are more part of the co-researcher, which is Dr. Noyati, because has, you know, my background is more on the chemicals and materials. So these are the method that been added in this research. So they will use the E. coli to be test using the agar diffusion test. And then we also will go to
Sorry,
the
Doctor, to interrupt.
Yeah.
There is another 5 minutes more left.
Okay, so this is the biocompatibility test. So this we will start with the sterilization of the scalpel, and then the cell seeding, as well as the cell availability to measure the antimicrobial properties. So this is some of the preliminary result at the stage 1 that have been done by my student Tivia at her elective research. So as you can see, that is the natural color of the alginate agarose hydrogel, and we managed to characterize using the SEM. So if you can see, the surface microstructure have been really rougher, more compact network structure with the heterogeneous pore for the alginate compared to the combination. So nevertheless, the agarose was significant in the composite agarose alginate, show was more homogeneous and porous structure. So this is part of the research result, the preliminary result, where we also see we analyze the swelling ratio as well as the degradation rate. This is part being done by Dr. Nohayati Yusuf's student, where he did the degradation rate to see using the citrate and EDTA, where you can see the degradation time of hydrogen bit after encapsulation of the shed. The 10 micromolar citrate and 10 micromolar EDTA demonstrate 2 times longer duration than using the 100 micromolar of the citrate and EDTA. So this is the FTIR of the hydrogel combination of arginate and agarose. So this result show very good miscibility between the arginate and agarose. And from the spectra obtained, the composite arginate agarose bit process similar observation peak to the pure arginate and pure agarose. And reason being, the 2 or more polymer are added, the absorption peak form is the reflection of its component. So this is the summary of the research, and as I mentioned, it's still ongoing research at the stage 1, and all the data gathered and suggested the pore size and the molecular interconnection are essential in determining the solute absorption and diffusion of hydrogel. And we hope this civil nanoparticle and HA incorporated can successfully induce the arginate agarose hydrogel in order to study the behavior and the potential sources for future development of the wound healing application. And further study, we would like to produce the hydrogel with the highest rate biocompatibility and ensure that this dressing heavily depends on the understanding of the healing mechanism. By having these properties, we will need to be studied and designed successfully in such composite, and ideal wound dressing can result in quick healing and affordable rate with the limited discomfort to the patient, biocompatibility, and the substance used to accelerate the repair step. So these are some of the expected limitations in the research, and these are some references that have been used by my student. That's all from me. Thank you very much.
Wonderful speech. So let's move on to the Q&A session. Okay, Doctor, we have one question from Facebook.
Okay, as for the biocompatibility, what the type of cell did you use and why? Okay, as I mentioned, the cell that been used is purchased from the human cell line, not the HDAF, where this part actually I'm not sure because it's more on the Dr. Yati, because she's the molecular cells person. So we are still ongoing stage and we not come very deep to this part yet.
Okay, okay, Doctor, there is another one question, a long question.
So what is your opinion about the nanometalite? Do you think it has different property and affinity compared to micro size of hydroxide as biomaterial? To be frank, I'm not sure about this because as I said, I'm still a bit at the surface level, and this is quite new for my research lah. So that's why we tend to do a lot we tend to gain a lot of comments or any information, and yeah, I'm not sure to say if I say it's a different properties and effectiveness. It might give a wrong information, but however, I will take note on this question and maybe I can get back to the answer, right?
Doctor, we have another question.
Okay, what happens if you use only one hydrogen in the patch, and how to reuse the patch? As I mentioned, okay, for example, if we only use the arginate, it had been developed previously. Arginate had been developed, even only one has a hydrogel for the wound healing. But in my research, we try to combine this arginate and agarose because we want to see more remarkable properties from this material. So there's still a drawback when they use this only one hydrogel, for example, arginate, where it cannot give some of the properties that can provide a good material for the wound dressing.
Doctor, we have another one question.
You might know the stability of the synthetic hydrogen. What is the storage condition for this material? Okay, for the storage condition, is we do keep in the room temperature. It should we don't have to keep whether unless for the cell attachment, yes, we need to keep it in the less than 0 degree. But for the only the hydrogen itself, it can be kept under the room temperature.
Okay. Thank you, Doctor, for your
All right, thank you
response.
very much. Thank you,
Okay.
Aisha. All right.
Welcome.
Okay,
Okay.
can I stop sharing or something?
Yes.
Where is it? Leave the studio, is it?
Yeah.
Okay, thank you, Aisha. All right.
Thank you, Doctor. Okay, welcome. Okay, thank you. Okay, moving to the next. Kindly to remind all on the audience are encouraged to ask any question in Facebook Live or YouTube Live platform. Ladies and gentlemen, moving on to our sixth keynote speaker for today, Associate Professor TACHM Dr. Nik Ahmad Nizam, Nik Malik, is a Director of Center of Sustainable Nanomaterials, CSNano, University Technology Malaysia. Lecturer at Department of Biosciences, Faculty of Science, UTM. As a professional chemist and technologist and chartered chemist, his expertise is applied material science, where his research area involves using materials in biological and medical applications. He is a program leader for UTM Trans-disciplinary Research Grant, UTM DR17, which is antibacterial wound healing application of bio-inspired green silver nanoparticles. His current major research is the development of inorganic antibacterial agents, especially green silver nanoparticles. So his title for today is Sustainable Nanomaterial, Biosynthesis of Silver Nanoparticles. Please welcome, Doctor.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Doctor.
Okay, thank you very much, Ms. Aisha, for the chairperson, as a chairperson for today's event. Okay, so welcome everyone to BioNanoSem, our bionanotechnology research seminar. So this is my part here where I will give you the information, some information. Hopefully for my part today, I will give light information about the research that we have done, okay, but not too technical. So maybe you can grab this information, okay, from my talk today, and then this actually good for your future research, okay. So the title for my talk today is Sustainable Nanomaterials, which is the biosynthesis of silver nanoparticles. So today we have heard about the biosynthesis, okay, biosynthesis of the metal nanoparticles from the plant extract, from the, what they call this, microalgae, right, from other resources, and also different metal, and not only just silver, there is also metals, okay, other metals like zinc oxide and so on. Okay, so today's talk, I go to the next slide. So this is my research project that I obtained, okay, for the last few years. This one is very big, UTM Trans-disciplinary Research Grant, and with the title of Antibacterial Wound Healing Application of Bio-Inspired Green Silver Nanoparticles. So there are actually 5 projects under this program, so which is a very big program lah. Okay, So it's involved biosciences and also chemistry. It started 2 years ago, and there are actually many things that we obtain from this project. Okay, because it's a research. Research ni is something like we have the what they call this trial and error, and then after that we find a new things. We explore new things on that research. Sometimes it might be deviate from the proposal that we get that we prepared at the early stage, and then after that we try to modify it. So that is actually research. So we are not stick to the proposal, but we try to expand it. We try to look at the different angles. Okay, and then another one. So Alhamdulillah, I got this FRGS grant, Green Biosynthesis, Characterization, and antimicromechanism mechanism of cyanoactive using Ficus letodia. So mas cotek lah. Okay, Alhamdulillah, we got that. Okay, okay, we move on to the next slides. So I'm from Sustainable Nanomaterials. So this is actually the combination of the word sustainable and also nanomaterials. So sustainable ni, if you want to go, if you want to understand the definition of sustainable, actually I like to look at the what they call this, the define definition of the sustainable, the word sustainable itself. Okay, so the word sustainable itself is adjective. Number one here is able to be maintained at a certain level or level. Okay, number two, able to be upheld or defended. Okay, and then there is also I put it here, adopting sustainable practice, whether large or small, can have significant impacts in the long run. Okay, so sustainable here is something that we want to maintain it in the future. So that is sustainable. Sustainable meaning that is something related to a good future, related to a good environment, okay, related to something that will not harm to us. So that is a sustainable. Nanomaterials is a combination of the word nano and also materials. So if you can see here, okay, in the slide here, there are several types of nanomaterial. First, it can be divided into inorganic nanomaterials, organic nanomaterials, and so carbon nanomaterials. So for the inorganic nanomaterials, like for example, silver, aurum, palladium, copper, okay, and then organic nanomaterials, for example, like micelle, liposome, hybrid, and so on. Carbon nanomaterials, for example, like graphene, fullerene. So when you talk about sustainable nanomaterials, is something like whether the source of the synthesis of these nanomaterials is come from the sustainable resources, okay, or the application of these inorganic materials for our sustainable future. So that is what I can say about the sustainable nanomaterials. So in this talk, I will talking about the biosynthesis, which is one of the biosynthesis is one of the main aim in the sustainable nanomaterials. First, we'll look at this issue in the synthesis of nanomaterials. So as you know that, okay, if we want to synthesize silver nanoparticle, okay, or silver particle, or silver oxide, or metal oxide, there are actually many techniques that we can do. Okay, if you can see here, there are top to bottom. Top to bottom meaning that the it's come from the very big particles, and then we are using like ball milling, laser ablation to make it smaller, to come up with a particle which is smaller. Okay, so that's top to bottom. For bottom to up is that we have the ion, okay, for example like silver ion from silver nitrate, and then we are using all of these techniques, okay, either chemicals or using green synthesis technique to come up with the particles, okay, to produce particles, which is in this case we are using Ag+, okay, not using. Actually, the process is that we have a silver plus, and then we are using reducing agent to come up with a silver nanoparticle. Okay, Ag plus, and then Ag0 here. Okay, Ag0 here. Okay. Okay, excuse me, can I stop a little bit on this? Okay.
Okay, Doctor, you can. Did you facing any problems in sharing your slide?
Okay, I'm sorry about that. Okay, I'm going to continue my presentation. Okay, so talking about the nanomaterials, okay, is Ag plus to Ag0. Okay, so we have the reducing agent here. Okay, we have the reducing agent here. So this in a typical situation, okay, in typical chemical synthesis, we are using chemical reducing agent. Okay, for example, like sodium citrate and also sodium borohydride. But there are actually problem with these materials where it is dangerous and also expensive. Okay, and at this stage, okay, at this stage, if we are using this chemical reducing agent at this stage where we want to discard the supernatant or we want to collect the silver nanoparticle, there are actually additional steps, which is to treat this waste treatment. Okay, to treat this waste treatment. So it's actually add to the additional problem. Okay, because we want to treat the toxic materials, toxic chemicals from this process. Okay, right. So if you see actually in the bottle of the sodium borohydride, you can see there are 4 labels of safety. So you can see, you see here there is a flammable, okay, and there is also a picture of the tengkorak here, okay, showing that it is really toxic, it is harmful, and also is corrosive. So if you use sodium borohydride as a chemical reducing agent, we can ask the question whether the synthesis process considered as sustainable or green approach. I think it's not. And how we can handle this toxic waste. What is the production cost of silver nanoparticle and how its toxicity effect to human, flora, and fauna. Okay. So I think I need to go faster. Okay. So these are the biosynthesis of the silver nanoparticle. Okay, the idea, okay, is to replace the sodium borohydride, okay, using biological resources. So the plant extract is our selection, okay. But actually there are other biological source that we need to consider, okay, that we can consider. So the selection is actually what is from our research is that from our project. There are a few things that we need to consider before we can select this sustainable reducing agent. First is high reducing ability. Second, high antioxidant activity. Third, high flavonoid and phenolic compounds, and also it's abundant. So these are the analysis that you can do. Okay, if you want to use this biological resource as reducing agent. Okay, so there is a combination of organic and also analytical chemistry. So where you can use chromatography or spectroscopy technique, you can determine the TPC, TFC, DVPH, FREP, and also using FTIR to know the functional group, and also use other suitable techniques. Okay. So thanks to Atia, one of my student. Okay, she's working on this biosynthesis of silver nanoparticle, and she has determine the antioxidant activity of some of the important plant, Malaysian herbal or ulaman, okay. And then what's important here from this data is that there are actually a good correlation between this antioxidant activity and also formation of silver nanoparticle, where the higher the antioxidant activity will result on the higher formation of silver nanoparticle. So in this case, Justicia gingerosa has a very low antioxidant activity, very low FRAP, okay, and also very low strength of ferric reducing capacity, and also very low DPPH percent. And then it give higher, what they call this, lower formation of silver nanoparticle as compared to Persicaria odorata. So Persicaria odorata is the kesom, okay, kesom. It has a high antioxidant activity and also high reducing capacity. So there is actually correlation between this antioxidant activity and also the formation of silver nanoparticle. Okay, and we have done this, okay, synthesis of silver nanoparticle from the kesom, and then from this optimization, from the experiment that we have done in the lab, so we optimize the synthesis parameter, and then we copyright the synthesis itself, the process of manufacturing this silver nanoparticle itself, okay. But then there is what they call this, the disadvantage of biosynthesis silver nanoparticle is that the particle size or particle shape is not homogeneous, it is heterogeneous. Okay, so actually there is also this advantage of biosynthesis, okay, but it depends on the application. Okay, I think I need to go a little bit faster, okay, because the time is not it's not too much on this, okay. Okay, I want to share with you a little bit information about how we can design sustainable project for developing biosynthesized nanomaterials. So this is actually very good if you want to go into commercialization of your research product. So what we can do is that we can use this TRL or technology readiness level strategy, okay, which is actually have been done, introduced by NASA, okay, and then mostly Malaysian Ministry of Science, Technology and Innovation use this for the identifying the research level, okay. So there are actually 9 level, TRL1 up to TRL9, and then it start from the basic principle or research hypothesis up to the come up with the prototype and so on. So actually for us, sometimes we just involve on the TRL1 to TRL3 only. Up to the papers is on the up to the proof of concept. But when it comes to the TRL4 to the TRL9, we need to have more funding on this. So maybe in the future, what you can do is that, okay, for all of the researcher here, okay, what you can do is that you can actually plan ahead your research, not just only up to the proof of concept, but you can go up to the RL4 and so on, okay, up to the technology development and also business development. Okay, as a summary for my talk today, okay, so actually my talk today is not much on the technical issues, okay, and if you want to ask related to the project that we have done, so please let me know, okay. So what I can summarize from this talk and also from the experience in doing this research related to the sustainable nanomaterials is that, okay, synthesis or preparation of materials using green or sustainable approach is considered as one of the area in the sustainable nanomaterials. Okay, and then for the biosynthesis of silver nanoparticles, actually we solve the issue of toxic and also hazardous substance, especially when we use chemical reducing agent. Okay, and then if you want to use plant materials, if you find out that there are possible plant materials, you need to do plant analysis. Okay, and then you need to understand a little bit about the organic chemistry and also analytical chemistry, because if you can understand the phytochemical compounds in the plant, you might be able to reduce some steps in the research. Okay, maybe if the antioxidant activity of the plant is really low, okay, so might be it does not contribute to the formation of the silver nanoparticle. So it's not just only for plant materials. Maybe there are actually biological resources that we need to we can consider. For example, like honey, okay, madu, and then maybe the bacteria, the isolated bacteria. And then there is actually, if you use this sustainable nanomaterials, it actually will give an advantage for future commercialization, where it can reduce the production cost, and also we can reduce the what they call this impact, negative impact to the environment. So these are the ongoing and future projects of me lah actually. Okay, first is fabrication and characterization of biosynthesized green silver nanoparticles immobilized on synthesized zeolite. So we are trying to immobilize this green silver nanoparticle onto the other carrier system. Okay, and then we want to apply this green silver nanoparticle as antibacterial wound healing agent, and then we want to and also we want to try to synthesis this silver nanoparticle using various source, algae, honey, marine bacteria, isolated bacteria, enzyme, and so on, for various application as antimicrobial agent, antibiofouling agent, and so on, and various angle of study. We also what we call this, involve computer simulation. We are trying to commercialize some of the product. We study the physical chemical properties, want to apply it in biomedical application, and so on, so on. Okay, so there are actually many room of improvement for the biosynthesis of silver nanoparticle. So I would like to acknowledge all of my postgrad students, okay, my collaborator, and also the research projects, the funder of this project. Okay, so I think with that, thank you very much. You can scan this QR code, okay, using your QR code, not using my sejahtera, using your QR code, okay, to see my, it will go to my website, okay. So with that, Aisyah, I will get back to you.
Okay, thank you, Doctor, for the wonderful sharing. Okay, let's move on to the Q&A session. Okay, Doctor, we have one question in Facebook.
Okay, do you want me to read this?
I can also read to you.
Okay, go on.
Doctor, in your previous research, what is the ratio between plant extract that be needed to reduce silver ions?
Okay, for the ratio, there is no specific ratio that student did so far actually, because when we want to synthesis silver nanoparticle, okay, we come up with try and error. We try to come up with 1 millimolar of what do you call this, 1 millimolar of silver nitrate, okay, silver nitrate, and we try to come up with a different what we call this concentration of the plant extract. Okay, so the ratio actually is different, depend on the plant extract that we use. Like I said in my presentation, okay, each of the plant they have a different antioxidant activity. or different FRAC value or DPPH value. So different value will give a different what they call this formation of silver nanoparticle. That's why actually one of the techniques that we use before we go further is to optimize the synthesis parameter of the silver nanoparticle, the synthesis of the silver nanoparticle using this plant extract. Okay, so there is no specific ratio on this. Okay, it depends on the plant itself. Okay.
Okay, Doctor, we have another question. Okay, Doctor, what is your comment or prediction on the continuous use of plants for silver nanoparticle synthesis? This is pandemic time. It is expected that the use of sanitizers with AGNP will be booming over the years.
Yeah, actually, based on my prediction, based on my prediction, we will use this silver nanoparticle, especially not just from plant actually. There are actually commercialized silver nanoparticle, especially from China lah. Okay, especially from China. So they produce silver nanoparticle from various techniques. Sometimes they make it what they call it. They did not show the method that they use. They just prepare in the lab and then sell it in the form of colloidal, colloidal silver. Sometimes very high concentration of colloidal silver, and then the manufacturer bought this here and then put it as one of the active ingredient in the hand sanitizer. Okay, hand sanitizer. So actually silver nanoparticle ni it can be used for hand sanitizer, but I do not want to claim that it can kill what they call the virus. So it's actually it's dangerous to say that. Okay, however, this silver nanoparticle, if we can use it properly, it can be used to kill most of the microorganism, which is not just only bacteria but also some of the virus and also fungus. So that's actually what I want to say lah. But based on the my prediction, the silver nanoparticle will be used in many application, not just in the hand sanitizer. However, it's based on our competitor lah. Okay, so that's my answer.
Okay. Thank you, Doctor, for the answers and the wonderful sharing. Okay. So we will move on to our next presenter. Thank you, Dr. Nick. Okay, next in line is our fourth oral presentation for today. I would like to welcome Miss Atia Abdul Hadi. Let me introduce about her. She is successfully obtained her Bachelor of Science in Industrial Biology and Master of Science in Biotechnology in University Technology Malaysia. With the desire to venture into interdisciplinary research, she is currently pursuing her PhD at the Department of Biosciences under the supervision of a Associate Prof. CSNM Dr. Nik Ahmad Nizam, starting from 2019. Currently, she is working on the antibacterial activity of the green silver nanoparticles towards resistant bacteria. Her research interest is green synthesis, silver nanoparticles, antibacterial assays, and nanoinformatics. So her title for today is In Silico Interaction Analysis of Silver Nanoparticles Towards Opportunistic Pathogens Protein Using Stage 5.0. As usual, you have 10 minutes for presentation and 5 minutes for Q&A session. Miss Atia, please welcome.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Does my slide appear?
Yes, clear.
Okay. So I can start now. My name is Atia Binti Abdul Hadi. Thank you to the moderator. So my title for today is In Silico Interaction Analysis of Silver Nanoparticles Towards Bacterial Protein Using Stage 5.0. So basically, since in the morning we have heard so much about silver nanoparticles. So today I will focus on the antibacterial interactions. So we know that silver nanoparticles have outstanding credibility in antibacterial activities. So here I highlight the three important key points of my presentation. Firstly is the interaction analysis. So here I will share a bit about stage 5.0, which is a screening software I use to see the interaction of silver nanoparticles. So secondly is the silver nanoparticle itself as the compound. And thirdly is the bacterial protein, which is the target of the whole antibacterial activity. So just briefly, when we say about in silico, so actually it defines a really big scope. So the name in silico actually comes from when we do computational approach on silicon. So silicon is actually a chip. So it defines the chip we use in the computational. So simply we can say that in experimentations, methods or predictions, we use a computational approach. So why we use this computational approach? First, because it can produce high simulation accuracy, and also when we want to discover drugs, and also for example that we want to design any molecular compounds. So actually when we use this method of in silico, we can save a lot of time by screening the compound and also without risking any tedious lab work. And also when we do in silico works, it is beneficial when at times like this where we cannot enter the lab work, and when we want to do lab work, we need to choose which lab work that we want to do. So actually there are lots of benefits when you use in silico works. And as I mentioned here in this diagram, we can say that there are lots of scientific literatures, millions of articles, and now they are put into the database. So actually we can get higher accuracy results based on the data mining from the results. And also we can predict what diseases, what compounds, what are the cells and the functions involved. So actually I can say that in silico is the best friend of experimental works. So my research problem, so basically I've started the work with biosynthesis of silver nanoparticles. Then I optimize the silver nanoparticle production using Persicaria odorata, as mentioned from Dr. Nip. And I did in vitro antibacterial assay using these three techniques, these diffusion techniques, where we get zone of inhibition which is quite large, and it is comparable to antibiotics. And when we test with minimum inhibition concentration and minimum bactericidal concentration, we got good results from our biosynthesized silver nanoparticles. However, the gap of the study is the bactericidal activity of the biosynthesized silver nanoparticles is not yet extensively studied towards resistant bacteria. So there comes the interest where we delve into the resistant bacteria. Just a simple introduction why I want to focus on resistant bacteria. This is because as we all know, when bacteria, virus, fungi and parasites, they no longer respond to medicine, it will make infection harder. So when infection is harder to treat, regardless of any designs of antibacterial agents, we cannot cure because the bacteria has become powerful than the compound, than the antibacterial agents itself. So I would like to elucidate the antibacterial mechanism towards the resistant bacteria using this overlap approach in vitro, which I already got the results, and also the in silico approach. So this is the rough framework of it. Okay, when we want to do in silico works, we need to have a target and also a compound. So the compound is biosynthesis nanoparticles. So actually there is also a computational work there which involve computational chemistry as explained by Dr. Fazira earlier. So I would like to focus on this, which is the target where we want to screen the target binding protein. So in this particular area, I want to choose two model organism, which is methicillin-resistant Staphylococcus aureus (MRSA) and also Pseudomonas aeruginosa. So MRSA represents gram-positive bacteria. P. aeruginosa represents gram-negative bacteria. So actually there is a problem when we want to choose which bacterial protein. There are too many bacterial proteins and we know there are rough mechanisms involved. But however, which bacterial proteins that we want to choose? Is it based on the literature or how? So actually this is where the screening using in silico tools comes in handy. So actually this is the first part.
Sorry, Miss Atia, to
Yes?
interrupt. There is another 4 minutes to
Okay.
finish the speech.
So we will use Teach 5.0. So the objective is to study the interaction between AG and P towards the two chosen bacterial proteins, two chosen bacteria, and to reduce the bacterial mechanism. So this is the interface of the stitch. So we can it is very advantageous because it is an open source and it is free, so everyone can use, and also it has constantly expanding database. So for example, like this, we just enter the compound input using chemical structures and everything, choose the organism that you want. It also has human proteins also, and obtain the network. So we can see that there are various database incorporated in this network. So the results and discussion. So this is for P. aeruginosa. We can see that the network is we choose the confidence score of 0.8 above, where we see the compound target interaction. So we can see that it targets the multi-drug antibiotic resistant efflux pump system, which is at the outer membrane protein, and also attacks the inner cell cytoplasm's protein, the intrinsic proteins. So this one is for the MRSA. So basically we can see that majority of the binding of civil nanoparticles is towards the intrinsic protein, which it disrupts the cell homeostasis. Okay, so basically when we do the network analysis, so we outline it with the antibacterial mechanism. So actually there are around 7. So based on the results, we can say that the antibacterial mechanisms is different because there is difference in the cell wall of the gram-negative bacteria and the gram-positive. So basically gram-negative, it interacts with the efflux pump, which is at the protein membrane, at the membrane of the protein. So for the MRSA, it interacts inside. So this is the conclusion. So we can see that the functional protein network is clearly derived. For gram-positive bacteria, we can see it causes major intrinsic destruction. So that's why the MRSA is killed by the AGMP. And also, I can say that the the gram-negative bacteria is also obstructed by the civil nanoparticles strongly. So actually this result can be further used in molecular docking and dynamic simulation to actually visualize the interaction. So this is my acknowledgement to my highly motivated and ever supportive supervisors and co-supervisors and the grant and also the sponsorship GP Malaysia. So that's all. Thank you.
Okay, thank you, Miss Atia, for your wonderful sharing. So right now we will move on to the Q&A session for about 5 minutes. Okay, Miss Atia, we have one question. Okay, let me read for you.
Okay.
Does Teach database also include progressively mutating bacteria?
Yes, for example, MRSA, there are, when I see that the input organism, there are lots of Staphylococcus mutants, MU50, PA01. So actually, if the database because the database is continuously expanding. So I expect that more mutating bacteria will be included, since from the literature we can say that since 2020, 2021, many are shifting its what we say antibacterial works towards the resistant bacteria. Since we know that the COVID-19 is also accelerating the
Yeah.
antibiotic resistant problem.
Okay, for another question. Do you plan to try other computational method, and how do you compare stage 5.0 finding with experimental findings?
Oh, actually, I decided that I want to compare with the cytoscape, but I think need some time to explore. The cytoscape really how I say does it really can give the results that I want. So when we the second question is compare stitch with the finding. Yes, actually uh, when we compare the finding, actually it complements. For example, that when we use stitch, it says that it attacks the nitrogen oxygenase inhibitor something. So we can plan to choose which antibacterial experiments to verify that. I was thinking of it can help us to choose which experimental works that we can do to strengthen the results from the stage.
Okay, there's another question more. Okay, what makes AGNP different from current antibiotics used to cater the MRSA and PA infection? Is there any difference in terms of the mechanism between AGNP and antibiotics?
Okay, I didn't include this one, so because I know the presentation will be longer. Actually, I've compared the antibiotic of chloramphenicol. I did the network analysis with the same MRSA and also P. aeruginosa. So actually, we can see that the antibiotics work by binding towards lipid protein. So when we compare with the silver nanoparticles, I think it is quite how I say intelligent ke? Because actually it targets two things. Silver nanoparticles, first it will bind to the pore membrane. When it binds and actually it makes the membrane haywire, so more nanoparticles will come into the cell. So actually that one is a really excellent work of the nanoparticles. So for example, antibiotics, uh, it is really dose dependent, right? We need to
Yes.
increase the dose at a higher dose when it doesn't become efficient. Why? Because it doesn't able to penetrate inside the cell, because mostly this antibiotic will work inside the cell. It works wonders inside the cell, but it needs to have like something to bind specifically towards the cell wall actually. I think actually both works, but I think the synergistic effect is better. That,
Okay. Okay,
yes.
Miss Atia, thank you. Do we
Thank
have
you.
any other question? Okay, thank you, Miss Atia. Okay, so next we will go to the finally. We would like to welcome our final oral presenter for today, which is Miss Salma Izzati Sinar Mashuri from UITM Shah Alam. Let me introduce. Okay, Miss Salma Izzati Sinar Mashuri is a student at UITM Shah Alam, currently pursuing a Master of Science in Applied Chemistry. Her education background is Diploma in Science at UITM Tapa and Bachelor of Science in Applied Chemistry at UITM Shah Alam. She is a member of Institute of Materials Malaysia, IMM, the Graduate Technologies and in Malaysia Board of Technologies, and Vice Secretary in UITM Postgraduate Chemistry Club. Her research interests focus on photocatalysis, renewable energy, and environmental chemistry. So for today, her title is zinc oxide / cadmium sulfate aluminum oxide support photocatalysts in organic pollutant degradation under LED light. Please welcome.
Bismillahirrahmanirrahim. Thank you to the chairperson, Ms. Aisha. So I am Salma Izzati Sinar Machuri from UTHM. Would like to present about zinc oxide cadmium sulfide photocatalyst in organic pollutant degradation under LED light. So annually, about 300 to 400 million tons of organic pollutant has been produced by industries such as pharmaceutical, agriculture, food and textile. So this industry produce abundance of organic wastewater. With the unwell treatment, it will cause the water pollution. So this industry is searching the best technology that has lower production cost, lower handling cost and effective technique. So photocatalysis has been proposed as the technique to overcome the problem. So conventionally, zinc oxide was used as the photocatalyst because it has good thermal chemical stabilities and also stable optical features. However, there are some problems with zinc oxide such as fast electron hole recombination, large band gap because it only active in UV light. So to overcome the problem, cadmium sulfide was proposed in this research because cadmium sulfide is the photoabsorbance in the visible light and it shows high potential based on previous study in degradation of organic pharmaceutical waste. So the objective of this research, first, synthesis and characterize the photocatalyst, zinc oxide cadmium sulfide. Second, to study the performance and photocatalytic activity under LED visible light source. So compared to the other study right now, the light source used is halogen, which we know that halogen need high energy compared to LED. Alright. And the third one is to investigate the active species that responsible for MV degradation. Okay, for scope today, we start with synthesis of photocatalyst, second characterization, next photocatalysis reaction. We want to know the optimization of parameter, and lastly scavenger test and recyclability test. So this is the synthesis method of zinc oxide cadmium sulfide by wet impregnation method. Okay, so the composition between zinc oxide and cadmium sulfide during this research was varied. Different molar ratio. So we have Z3C1. So Z means for zinc oxide, C for cadmium sulfide. So this one is rich in zinc oxide in the composite. Next is the same molar ratio between zinc oxide and cadmium sulfide. And lastly, rich in cadmium sulfide, which is Z1C3. This is the photocatalysis reactor that equipped with 21 watt LED visible lamp. Alright, we entered to the characterization. This one is optical characterization. So from UV vis and IR, we can get the reflectance age. So to study the band gap, we calculate through the top plot. So we can get that band gap of pure zinc oxide originally is 3.30 electron volt. So when we added more cadmium sulfide, the band gap become decreased from 3.30 become 2.46 electron volt. So we already know the band gap. How about the position of the valence band and conductive band? So from the Mulliken electronegativity, we can calculate here that from the valence band here that not significant difference between the photocatalyst. However, in conductive band shows the significant difference from pure zinc oxide with the loading cadmium sulfide. So the lowest conductive band we get is 2.34. So we move to the morphology analysis. This is the pure zinc oxide. Meanwhile, this one is the pure cadmium sulfide. So when we introduce a small amount of cadmium sulfide, the morphology almost similar, which is variety of tiny 3D geometric and formation of coral-like structure. With the similar amount, if appear as nano sheet layer with small agglomeration at the edge and higher in cadmium sulfide shows agglomeration with small hexagon flakes. Okay, next is the XRD analysis. the triangle one is the zinc oxide peak, meanwhile for the circle one for the cadmium sulfide. So it can confirm in the composite that we can see both characteristic inside the photocatalyst. So the photocatalyst shows as crystalline. Okay, what happened to the surface analysis? So compared to the pure zinc oxide, for surface area, when we loaded more cadmium sulfide, so the surface area become lower, the total pore volume become decreased and mean pore diameter become increased. However, the type of pore still in mesopore. So what is the advantage of mesopore? Because it has hysteresis from isotherm plot here. So what is hysteresis? Hysteresis is where the material can able to do adsorption and desorption. All right,
Sorry,
next
Miss
we
Salma.
move.
You have another 5 minutes to complete.
All right, okay. So we move to photocatalytic studies in molar ratio between zinc oxide and cadmium sulfide. We can see here that Z3C1 achieve 100% degradation within 130 minutes. This is due to rapid electron transfer at the interface between zinc oxide and cadmium sulfide. So it decreased the recombination inside the zinc oxide of electron and hole pair. And then the presence of cadmium sulfide, it reinforces the visible light absorption. So more incident photon will be harvested and increase the photoactivity. Next is the initial concentration of MB solution. So we can see here in 3 milligram per liter shows higher degradation because hydroxyl radical effectively collide with the MB molecule. However, in lower initial concentration, so lower methylene blue pollutant available inside the solution and then less adsorption. So it makes the degradation lower. Meanwhile, at the higher concentration, because too much MB pollutant inside the solution, so MB molecule hindered the path length for the photons to penetrate the solution. Next is the catalyst loading. Okay, we can see here that increase the catalyst loading can increase the adsorption. However, when less amount of photocatalyst is loaded, so less amount of methylene blue in contact with photocatalyst, so lower degradation. Meanwhile, too much photocatalyst can cause Rayleigh scattering phenomenon. This is caused by the photocatalyst particle size and abundance. So less amount of light can travel through the wastewater sample. Okay, next is pH of MB solution. The best one is pH 9 because more free hydroxyl radical produced by hydroxyl ion and hole. For pH 3 and 7 shows less degradation because of the solution. So we want to determine either this photocatalysis activity is confirmed photoactivity. So we do the adsorption test. So the highest adsorption can achieve only 44.97. So area under the graph more than blue line is confirmed is photocatalytic reaction by degradation by the active species. So we want to know what is the active species available inside the solution. We do the scavenger test. So the reagent can is determine the specific active species. So we can see here that electron and hole is generated from the photocatalyst. However, the major active species that degrade the methylene blue, we can see here is hydroxyl radical and also superoxide. And the recyclability test can be up to 4 cycles. And then the proposed mechanism is, okay, firstly, we see at the valence band where originally here is the electron. So when photon from the light source attack the electron will obtain the energy and then it will excite and jump towards the conductive band, leaving behind a hole. Okay, so these both simultaneously, electron and hole, will travel to the surface. Okay, we see at the valence band what happened. When water molecule react with the hole, it will become hydroxyl ion and hydrogen. And then further the reaction of hydroxyl ion react with hole, it will become hydroxyl radical. So this radical responsible to degrade the methylene blue. So at the electron, when react with diffuse oxygen, it will produce superoxide. So superoxide has two role here. First, directly degrade the methylene blue. Another one, when react with hydrogen ion, it will become OH2 radical. So react with another OH2 radical will become oxygen and hydrogen peroxide. So hydrogen peroxide react with superoxide will become hydroxyl radical and hydroxyl ion. So the radical will react with methylene blue and degrade it. Okay, another role for electron is when it react with hydrogen peroxide, it will produce hydroxyl ion and hydroxyl radical. So this radical will degrade the methylene blue. So as a conclusion, we can use zinc oxide cadmium sulfide because it has high crystallinity, high surface area, has 3D morphology and lower band gap. Okay, for the best photocatalytic performance can achieve is 100% within 90 minutes. So the scavenger test proved that the presence of electron and hole generated from photocatalyst. Meanwhile, hydroxyl radical and superoxide were active species that are responsible to degrade methane blue. So zinc oxide cadmium sulfide is the promising photocatalyst in degrade methylene blue solution and can be further analyzed for the other type of organic pollutants. So thank you.
Okay, thank you, Ms. Salma, for the fruitful sharing. Okay, now we move on to the Q&A session. Okay, there is one question in the chat room. Let me read for you. Okay. The question is, please justify how did you determine the energy emitted from the LED? So it's UV active or vis active?
Okay, to determine the energy emitted from LED is by the bulb that we use. So we know from the bulb, we use the visible active. So to know the material is active in UV or visible, we see from the reflectance age first from UV vis and IR result. So when it fall at the lower than 450 nanometers, so that one fall in the UV region, while for higher than 450 nanometer, that one fall in the visible region. So that is the first step that we want to know that our photocatalyst can be used what type of light energy to activate it.
Okay, thank you. Another question. Okay. You use cadmium to mask the disadvantage of zinc. However, did this composite compromise each other?
Okay. For cadmium and zinc, it has synergy between each other. However, if too much cadmium sulfide, it will become the self-attack based on the previous study also. So the optimum amount of cadmium to work with zinc oxide must be obtained. So that's why Z3C1 is the best photocatalyst.
Okay, Ms. Salma, is there another question? Okay, we have another question. Okay, have you tested the recyclability and reusability of your compound? How many times can we use it for dye degradation?
Okay, based on my slide, so 4 cycle can be met. So the lowest one is 46%.
Okay, 46%. Okay. Thank you, Ms. Salma, for
Okay,
the
you're
wonderful
welcome.
sharing. Okay, lastly, now we would like to also welcome our last invited speaker for today. Okay, I would like to invite CHM Dr. Muhammad Shazwan Shah Jamil. So let me introduce first. He is a senior lecturer at the Department of Chemistry, Faculty of Science, UTM, and a registered professional chemist with Institute Kimia Malaysia. He obtained his doctoral degree at the University of Manchester under the supervision of Dr. Alan Briston. He has expertise in organometallic coordination, catalysis, and material chemistry. His major research research revolves around the synthesis and application of palladium, rhodium, and copper compounds. It covers a wide range of synthetic chemistry backed up by extensive NMR studies, crystallography, and reaction monitoring of the catalytic systems. He is a member of the Royal Society of Chemistry, American Chemical Society, and Institute Kimia Malaysia. Please welcome Dr. Muhammad Shazwan with his sharing entitled Influence of Fluorine, Substituent of the Electronic Properties of this Complex. Please welcome.
Thank you very much to the chairperson, Ms. Aisha.
Welcome.
Assalamualaikum and good afternoon, everyone. First of all, I would like to apologize. I have a poor internet connection, so I cannot turn on my camera. But hopefully, my presentation will last to the end. So hopefully, the internet connection is good up to the end. So my name is Muhammad Shazwan Shah Jamil, as mentioned by the chairperson from University Technology Malaysia. So I'm going to talk about my work on influence of fluorine substituents on the electronic properties of rhodium chloride NaC complexes. So NaCs, N-heterocyclic carbons, or in short NHCs, are excellent ancillary ligand which are bonded to transition metals, and they have many applications in homogeneous catalysis and organometallic materials. So as you can see from the image, this shows the bonding interaction between NaCs, so the group on the left, and also the metal center, the d orbital of the metal center. So there are two main components, which are the sigma donating ability or sigma donor from the carbon from the NaC to the metal, and the other component is the pi acceptor or pi accepting of the NaC from the metal. So these two interactions play important role in affecting the properties of the NaC metal complexes. So the good thing about NaCs is that the modification that we can make in order to influence its steric and electronic properties. So such as here the backbone. So this is the backbone of NaCs. So we can change the substituent. So for example, this is hydrogen. So we can change with other element such as chlorine or fluorine, and this will eventually affect the carbon electronics. And also the other group, which is the nitrogen substituents. So here we can also change the substituent, which will affect the electronic properties of the corresponding NaC. And also there's a possibility for asymmetric induction. So we can have different group. So for example, the one on the left and the one on the right, we can have different group. So this will introduce asymmetric induction. And also we can provide kinetic stabilization with bulky ligands. So ligands or substituents with a bigger group or higher molecular weight. So theoretical studies have shown that fluorine being the most electronegative element, so the presence of fluorine will affect the bonding properties or the electronic properties of NaC. By introducing fluorine, it will lower the lowest unoccupied molecular orbital. So the diagram on the left here, so this is the level of the LUMO. However, when we introduce fluorine on the nitrogen substituent, this will decrease the LUMO orbitals, which will affect the properties. So if this LUMO is decreased, the energy level is decreased, the energy is decreased, this will increase the pi accepting ability of NaC. So going back to the second slide, so we have this pi accepting ability component. So by introducing fluorine, this will introduce, or this will add or increase the pi acceptor ability of the NaC. So that is from theoretical studies. So in the literature, we have found various metal complexes containing fluorinated NaC. So those on the left here is palladium metal. So you can see there are variation of the complexes and NaCs. So here, for example, we have this long chain, alkylated chain of substituents. And then, for instance, we have here, we have two different group, so this will introduce the asymmetry induction. And then we have these ruthenium complexes. So these ruthenium complexes are known as Grab catalyst. So Grab catalyst is named after the chemist who discover or who synthesize these complexes, Robert Grubbs, which won him a Nobel Prize in chemistry in 2005. So based on this, there's a gap where we haven't found the rhodium complexes containing fluorinated NaC. So in this work, we would like to explore how introducing fluorine into the NaC will influence the electronic properties of the metal complexes. So we have some of the previous studies from Wang, Ziner, and Binobite. So they synthesize rhodium complexes, but without any fluorine substituents. So in this study, we would like to explore how introducing fluorine will affect the electronic properties. So rhodium being the metal in the center, and we have cod. So cod is the 1,5-cyclooctadiene, is an alkene group. And then we have NaC here, and then chloride. So we maintain chloride and cyclooctadiene. We just change the NaC substituents. So the objective of this work first is to synthesize the fluorinated NaC precursors, and then to synthesize and characterize the corresponding rhodium complexes, and finally to investigate their electronic properties and evaluating their catalytic activities. So how the effect of the electronic properties will give an impact to their catalytic activities. So the first step is to synthesize to synthesize the fluorinated NaC salts. So this can be done by one-pot synthesis from the fluoroaniline, formaldehyde, and glycol. So this is the procedure that we adopt from the literature. However,
Doctor, sorry to interrupt.
yes.
You have another 4 minutes to present.
Okay, 4 minutes. Okay.
Okay.
So this is the literature procedure that we adopt from the literature. But however, we convert it to, initially it's a chloride salt, but we change it to tetrafluoroborate salt because we find that the product were more pure. So based on the NMR spectrum and also the elemental analysis, it proved that the tetrafluoroborate salt are more pure compared to the chloride, so less impurities. So these are the 5 variations of the fluorinated salt. So they differ in terms of the position and the number of fluorine. For example, NaC1 here, it has 1 fluorine on each arm, and the others they have 2, and some they have 3, and then also the position. So NaC2, the position is on the on the para and auto position, whereas for this one, both in auto position. And then next step is to synthesize the complexes. So this is the corresponding complexes. And for control, we synthesize two more complexes without any fluorine substituents to study the effect. Okay, so these are the X-ray crystallography of the structure. So these complexes are 4-coordinate distorted square planar. These are some of the value which I don't have time to explain. And next is the electronic properties. So the traditional way to measure the electronic properties is by using IR, infrared spectroscopy. So we study the bonding between the nickel and carbonyl. And then we can see how we change the NHC will give a different value of the carbonyl stretching frequencies. However, more recently, we have NMR techniques to study the electronic properties, such as we can use the Capri constant of the platinum, and then we can use phosphorus, NMR, and we can also use selenium. So NMR is more advantageous compared to IR because with NMR we can study different nuclei. We can study the nucleus of platinum, the nucleus of phosphorus, and nucleus of selenium, and also more wide range of the chemical shift. Like for the carbonyl, it has a very low range of stretching frequency, but using NMR we can have very broad stretching frequency. For instance, for selenium we can have, for example, minus 20 parts per million up to 800 parts per million. So the range is more wider. And then this is the selenium complex. Selenium is very sensitive nucleus for the NMR. And then this is the value that we got. So based on this value, we can see that we observe that those containing fluorine, their value of the chemical shift are much higher. So this indicates that the pi accepting ability of the NAC are more stronger, because here the relation between selenium and NAC. So we know that for NMR they study the environment, the nucleus environment. So the presence of the electron will affect the value of the chemical shift. So in the case of NAC, so lower value of selenium chemical shift indicates that the higher value of selenium chemical shift indicates that the electrons has been donated or has been transferred from the selenium to NAC. So that's why NAC here, which have higher pi accepting ability, will have higher chemical shift compared to the non-fluorinated analog. So these are some of the values of the NMR. And finally, we study the catalytic activities using transfer hydrogenation of acetophenone. So based on this study, we observe that those with fluorinated substituents have higher catalytic activity, and then those without the fluorine substituent has much lower conversion. So we use NMR to monitor the progress of the conversion. And then we use the linear regression analysis to study the correlation between the carbon chemical shift and the selenium chemical shift, and we got a straight line. This is to show the influence of the fluorine. So as a summary, the test of the catalytic activity shows that those NAC containing fluorine substituents have higher catalytic activity compared to the non-fluorinated element. So the rhodium 5, which the most highest fluorine, has the highest catalytic activity. So this order of reactivity is consistent with a number of simple NMR, such as the Capri constant of the NAC salt, the selenium chemical shift, and also the Capri constant and the carbene NMR of the rhodium complexes. So these are some of the ongoing and future works. First is to investigating the reaction mechanism of the catalytic cycle using density functional theory, and then to examine the catalytic activity of the complexes in other catalytic reaction. And then more recently, there are studies involving rhodium complexes for their biological activities, because normally it's platinum and gold and also part of copper that are more commonly for biological activities, but we also see a rising number for rhodium complexes, and also to investigate using other metal such as copper and silver. So I would like to acknowledge University Technology Malaysia Encouragement Research Grant, and I think that's it for me. Thank you very much for listening.
Okay, thank you, Doctor. Okay, now let's move on to the Q&A session. Okay. Let's see if the question is there. Okay, if there is no question, maybe we can proceed with our closing ceremony. Okay, thank you, Dr. Shazwan, for the wonderful sharing. Okay. Our sharing sessions for today's seminar has come to an end. As far as you know, we will have the meeting tomorrow to continue our final agenda. I will open the floor for further discussion by using WebEx platform with provided link via email and Facebook group. Thank you. And Alhamdulillah for our wonderful seminar today, we have come to our closing ceremony for second BioNanoSem 2021. Now, I would like to invite Dr. Juan Madmin to deliver his closing remark as the program director. Please welcome.
Bismillahirrahmanirrahim. Can you hear me, everybody?
Yes. Yes, Doctor.
Okay, hopefully there's no hiccups anymore. Alright, okay. So saya panjat pokok ni semata-mata tak nak ada sangkut lagi. Right, hopefully everything going to be smoothly. Assalamualaikum warahmatullahi wabarakatuh, and a very good day, everyone. Thank to Miss Aisha for her contribution as the Master of Ceremony. First of all, I would like to express many thanks to Associate Professor Technologist Chemist Dr. Nick Nizam as the seminar advisor. The seminar deputy directors Dr. Zul, Dr. Hanis, Dr. Farizal, and member of the secretariat committees, and all the respected participants. Dear esteemed participants, I believe that you all have done very well throughout this BioNano seminar. It is my great pleasure that you had also shared your wisdom and valuable research finding in this virtual seminar. I would like to reiterate that this seminar has provided the insight into recent research and cutting-edge technologies. It had gained enormous interest due to the brilliant researchers and the exceptional student committees who offer their research discoveries to the general public. This online event had provided impactful academic exchange and network possibilities of different scientific backgrounds. Either you are doing research on glass, cancer treatment, alginate, hydrogel, photocatalyst, or even algae, your input and discoveries are highly acknowledged. I also hope this event will serve as a stimulus for additional study and research in all these areas that we want to highlight as the emerging bio-nanotechnology disciplines. Through this platform, we had successfully presented 20 research orally, either from video or live Facebook session, and 5 posters presentation. I congratulate you for your commitment and active participation and wish you all the every success. Dear esteemed participants, I would like to congratulate the organizing committee for their hard work and devotion in ensuring event success despite the harsh circumstances of this COVID-19 pandemic. Although we cannot avoid minor technical hiccups, this seminar had been successfully virtually happened today. I myself had learned a lot today. It's not easy to keep calm, talking alone with a laptop despite being kicked out several times due to the uncooperating internet. Seriously guys, it's not easy. Thanks a lot to all the members of the Secretariat to make this second BioNanoSem successful. Dear participants, finally, on the behalf of the committee, I would like to express my appreciation to all respective organizations for sending their excellent participants to this seminar. Thank to Ibn Sina Institute for Scientific Research and Green Chemistry Research Group, my team in the University of Technology Malaysia. Thank to the Ceramic and Amorphous Group from UTHM, UMT, USM, and UITM. You all have been a wonderful participant. I would love to look forward to see you again in the third BioNanoSem, planned to be held sometime in August next year with greater audience and number of participants. We also plan that the third BioNanoSem will accommodate the participants from Malaysian Biomaterials Society, MBS, and National Nanotechnology Center mostly as our co-organizer. As been informed, the best presenter of each category will be announced tomorrow during our discussion. So I warmly welcome you to join the discussion tomorrow. With that, I would like to close my remarks. I officially announce the successful end of the second BioNanotechnology seminar, BioNanoSem with Bismillahirrahmanirrahim. Thank you for your attention.
Thank you, Dr. Juan Makmin. Okay, ladies and gentlemen, we have arrived at the closing ceremony for the second BioNanotechnology seminar this year, 2021, organized by the Center of Sustainable Nanomaterials UTM. On behalf of the Secretariat, we would like to deliver our appreciation to Associate Professor T.S. CHM, Dr. Nik Ahmad Nizam, Nik Malik, honorable guests, speakers, and participants for your presence in today's closing ceremony. Thank you everyone for your cooperation. Before we end the seminar, I would like to remind to all the winners for all categories throughout this session will be announced tomorrow via WebEx platform. We wish you all the best and we hope you enjoy this seminar and gain as much experience as you can. See you again next year. Assalamualaikum warahmatullahi wabarakatuh and have a good day. Take care and stay safe.